In this video, I'm going to show you how to use the friction part of the MC911 software. First of all, let's open some file with some torque and tension data. I'm going to select 3 files. Okay, as it shows up here, let's plot it against each other. I have angle and I have torque. Let's put load as a tension, and we can also have thread torque. So all of these 3 channels have been collected. It's shown here, and this tightening and loosening. Here we have used the torque tension transducer plus input torque as a torque and angle. So we have 3 channels here. So with these 3 channels, we can do some computation for friction and also compute the load factor. Let's go into the right side in the repository. Once you have 2 channels collected, this friction shows up. So click this. So we have a window here which calculates coefficient of friction. We need to provide some parameters which corresponds to our joint. First is nominal thread diameter, then bolt thread pitch diameter, then clearance hole diameter. This is supposed to be a M8 bolt, and pitch of the thread, and also outer diameter of bearing surface. So you have all these input that we have already entered, and also we can click this compute all loaded files. And here it's showing a calculated torque. Either because we are measuring input torque and thread torque, so our calculated torque, which is underhead torque, is we select this one, and this way we are computing the underhead torque. If we were tightening the nut, then we should be selecting here. Since we were tightening the head, we are using the underhead torque. So that's our calculated one. In another point is that the software is recognizing there are 3 channels here, which is channel 1, 2, 3. They are correspond to input torque, tension, and thread torque. We can select it and change it to different channels if you want to, but this happened to be as a default, and it works this way. For this, the way it's been hooked up, the input torque was hooked up to channel 1, tension to channel 2, and thread to channel 3. And these are the labels for the label and also units up for those channels. To perform the, another thing is, if you do not have a thread torque, then you would end up only with input torque and tension. It would be load cell and torque angle transducer. With these 2, you can compute the load factor and also total friction. If you change the load cell to torque tension cell, then you can compute the total friction, load factor, thread friction, and also underhead friction. To perform this, click on compute coefficient of friction. We're done. So if we exit it, all of these are calculated. You won't see anything at this point. You just exit it. So back to this view, we can now go into the graph setup and select, let's say, channel 4, and you have to scroll it down. All the way down, it shows you what things have been calculated. Thread friction, underhead friction, total friction, K factor. These are calculated based on what we just saw. So if you want to, for instance, see the K factor, which is the color is very faint, let's go change the color here. Let's go corresponding color, K factor. Let's use another color. Let's red and maybe purple or green one. Okay. So it's kind of messy looking here. We can maybe make it a little cleaner. The problem is it's been tightened up to a torque and loosen up. So coming back, it also shows the both sides. Maybe you're interested only the going up as a tightening. So let's go back to the graph setup. There is a feature here. Let's see, in Access. You can cut off what happens after the peak. Let's say we want to cut off the input torque after, let's say, 100% of the peak. So you will not see anything beyond that. Also, let's say on the load, we only see up to the 100% torque. And same with the thread torque. Let's say 100% of the. Okay. As you see, now we have 3 of them, but they're all auto scaled. This scaling is not set here for all of them, but it's all auto scaled. So if I take a click on this and move the cursor around here, we'll see the values of input torque, tension, thread torque, angle, and K factor of that point. This green part is the K factor. So you can you can click on it and pick a point. For instance, let's say my point. So it will pick that, and A shows up there, my point, and shows all the values of that point. Another way to do it is maybe you need to automatically pick few points. To do that, let's see what we can do. We already done this. I'm gonna delete this so I can redo it again. Okay, going to post processing. In here, we can go to auto pick, and then let's say based on input torque, we need, let's say, 5 points, starting 2 and intervals of 2 Newton meter. Field table, so we have 2, 6, 10, maybe increase it to 6. Field table. So we have all these values in there. You can also type it in here if you want to. So based on input torque, so at these values, we're going to pick up the other parts and show it on the table. So process all the files and process. So we're done. So let's go into what happens every time we do a change to a file, it highlights this save data button. You can click it and it will save to the file. So all of this information will be saved into this file, tt006.mci. So let's go into the groups and go into statistics. So we have 3 files loaded, and we can say we want to look at auto pick, and we want to see tension, and we want to see thread torque. Also, we want to see thread friction, underhead friction, K factor, total friction. And we also can see underhead torque as well. So click on report. So that's what we have. Let me blow this up a bit. Based on 2, 4, 6, 8, 10, and 12 Newton meter, these are the tension values and the statistics, mean values, and also thread torque values, and also thread friction, as you see here, and their values as the mean values of the thread friction. On the next page, you could see total friction, K factor. It's a little bit tight in here, as I see here. What we can do, we can go and maybe put in landscape mode. Okay, so easier to see in here. So we can see the underhead friction, total friction, then K factor for all those files. That's another way of seeing it. So this is the basic way of looking at all the data points for which corresponds to friction, and You can either pick it here, or you can use the auto pick and use statistics to come with a tabular way of showing the on the head friction, friction, and total friction, K factor, and thread friction.